Welcome to MATHurdays. Math's so fun, we do it on Saturdays. Really glad everyone is here, and let's go ahead and jump right into a routine and a rich task and talk about how math can be taught in this platform. On the second slide there, you all have links to MATHurdays. I'm getting the past ones up there today. And in addition, I also have the routine and tasks that we're going to jump into. If you found that your Google Slides is view only, just hit the refresh button. I've made it so you can now edit it. On slide 3 are where you can go for templates and past recordings. And I'm going to head over onto slide 4 and 5. I'd love to hear from you all. What are your successes and celebrations? What's going on in your world and more? Go ahead and pop that there in on slide 4 and 5. And you can do it using a text box, but you can also use images, emojis, bitmojis, GIFs, and more. And looks like we have Stacy. Is that you've been able to work from campus? How nice. I'm still waiting to get on campus myself.
Yeah, there's only about a half a dozen people there, but it's still nice to see somebody.
Mm-hmm. Absolutely. My little success and celebration. So my daughter and I have birthdays that are exactly a week apart. And so we celebrated hers on Wednesday. She had a lot of pink going on. And mine is this coming Wednesday, so I'm excited about that. And Julie, are you teaching summer school, and what grade level?
I am teaching middle school math, and I have one class of upcoming sixth graders, one class of upcoming seventh graders, and one class of upcoming eighth graders.
Oh, very cool. So you're going to see the whole school in a sense. And are you doing that face-to-face, hybrid?
Yes.
Okay, cool.
Yes, we are face-to-face, and it's been interesting because it's the first time our fifth graders have been in the middle school building. So they're very timid and unsure and still trying to figure out a new building and all. So we've got 4 more weeks. We're doing 5 weeks, and we made it through the first week. So
Lovely. My kids are still in school for another week. They've got 1 week left of this year, and then they're off for summer vacation. Laura, welcome. Buenos dias, and tell us about your click Beetle.
Good morning. Buenos dias, Teresa. So I'm concurrent. So I have some kids that are virtual and some kids that are in person. But our in-person kids, we go out to recess, and lately they just spend most of their recess screaming about the cicadas. There's a cicada. So like 30 minutes of cicada screaming. But we found a different bug. It was an eastern-eyed click beetle. Sorry, I had to say that twice. And we were doing some research, and my kids found out that they come out the same as cicadas. So like they have broods, and then they come out every couple years. So then my kids went off on this research tangent, which was really cool, not to have screaming about cicadas for a while.
That's really neat. I wonder how often they come out and if they follow the prime or composite number routine for coming out. Cool. All right, folks, thank you for everyone who's put some things on here. It's great to see other people who are exploring maybe new hobbies and summer school and more. We're going to jump right into our routine for today. And I am down on slide 6 if you want to head down. This is one of my favorite routines, Notice and Wonder. And because it's a birthday weekend at my house, we have been doing a lot with cake. And my kids have been talking about cake. We've been talking about slicing cake. We've been talking about square cakes versus circle cakes. So this comes out of the conversations that were happening in my home. I'm going to pop you into some quick breakout rooms for just a couple of minutes. And you can write anywhere on your slide. You have an animated image, either on slide 7, 8, or 9. 9, and you're going to put any noticings and wonderings. The most important part when you get into the groups is say hello to people, turn on your mics, and go ahead and start typing and talking and sharing. So I'm going to go ahead and make those now. Let's see. We've got 3 rooms, and you officially have an invite. Again, just minimize your Google slide, and you'll probably find Zoom behind it. And it's asking you to head into those breakout rooms. If you're listening to the recording right now, I have groups starting, and I always like to just give them a private moment for a minute so that they can say hello to everyone without me in that room, and then I'm going to start to head over in a sec here.
I'll go ahead. Cut it.
Julie, what's something you
And I also noticed that you can cut sectors of a circle from a square cutter. And I always have to wonder about the amount of
He does it so fast.
I know. That's why I'm thinking, is it 7 or is it not? Because 7's pretty hard to cut into.
If you look at the cutter, I feel it has 8 pieces over there.
Are you all wanting to pause this thing like me?
Yes.
Yes.
It's too fast. Okay.
So we do have the movement of the square cutter making circle
there
and
it is, a
triangular
square.
slices. Do you notice anything else in the image?
It's very interesting because usually cutters come in even numbers, not odd numbers.
Yeah,
So the
that's
fact that-
that's kind of what I was thinking when I noticed there were 7.
yeah.
Because I'm used to, 8th or 6th, or even 16ths, but
Right.
not 1/7.
Hello, everyone, and welcome back. Let me go ahead and share my screen in case you're choosing to watch through Zoom. This was such a fun one to bring up, and I would love to start off on slide 7. I'm really curious about these purple arrows on slide 7. So I found a connection between these two. The first one said, I noticed that the pieces look like they got bigger when they went to the plates. And also, what happened to the 8th piece that Sneaky Mickey is holding out on us? If that was you, did you find that these two comments were related together here? And what were you thinking?
I actually did not notice the relation between the two right away. It was just mentioned when in the discussion they said something about cutting into 8, and I go, but there's 7 plates. What happened? And so I watched really carefully. I'm like, where is that 8th piece going? And it's like, it just disappears. As soon as he hits the table, it disappears. So it's very, very weird.
It is weird, and it makes me think about, the area is still the same, or the volume even, but all of a sudden now the angle is different. So if we're teaching, degrees in a circle, how many were in 8, and then like how much bigger did it get when they stretch to the side of 7? Very cool. Let's head down to slide 8. What about the one with this blue arrow? You said, I noticed that there's a 3-tiered cake evenly being cut into 7 pieces. I'm curious why you put that down there and what math concepts you might teach about that.
Hi, Joyce, that's Colette. Well, actually, first of all, now that I've looked at it closer, because we were discussing how difficult it was to see how many pieces there were to start with, but we know there was only 7 plates. And now looking at it closer after what the person said in the first slide, you can see that it is originally being cut into 8 pieces, but all that you're seeing are the 7 pieces. So that changes the whole perspective. I basically probably would discuss with my students, okay, you have 7 pieces, 3 tiers. Is each person getting the same amount? Are the tiers all even? How much is in each tier? There's just all kinds of different problems that you can do with this and have fun with it.
Absolutely. Let's fill up the chat box real quick. It sounds like we could ask some really cool questions of our students at this point. I want you to think about a mathy question that you could ask with these couple of noticings and wonderings and pop it there in the chat. What questions could we ask students? So we've got a lot about multiples going on here. How many layers of cake to bake if you want 14 slices? What if there are 21 people there? What's the area of each tier? How much of this, how many plates would we need? What are the sizes if more people joined? So here we have like a reason to care about multiples or factors, the volume of the cake. Sometimes we'll extend this off to how many tiers does he have in the background? It looks like he's got about 9 more. What if we made a 9 plus 3 layer cake? Nice. And so part of the Notice and Wonder routine is having students develop questions that they can answer. And then it's the job of the teacher to decide which of these questions we're going to spend our math time on. That's a way that students are more invested in it and less about you all doing the question that I wanted you to do, and more on me analyzing the questions that you develop and finding one that relates to our unit. And on slide 9, there was also this orange arrow. If that was you, how many cakes did you see in the background? And what do you think this GIF would look like if it extended for another 30 seconds? What do you think he'd do with those?
I was the one that mentioned it, and it looks like there are 3 more stacks of cake. But it's kind of hard to tell if they're all 3 layers or if the one that looks like it's maybe on a plate that is the closest to the edge of the picture. It's kind of hard to tell for sure if it's 3 layers because of the dark of the icing behind it. But I think it'd be really cool to then extend, maybe have them work with the original cake and then extend that learning into the cakes behind it.
Love that extension and that it can be so student-centered. Awesome. And Kathy, you also mentioned some concepts here. I'm getting a vibe of surface area and volume with what you wrote in the chat. What made you think about that?
I actually wasn't thinking surface area and volume when we started, but it was based on everybody else's ideas and thinking that that's what kids would be really concerned with because the icing and the filling is really important and often that's what kids eat. So I kind of went that direction and then thought, okay, extend. Somebody had said start with 1 cake and then extend. So I think there's a lot involved in that. Start with one cake and then extend beyond that.
Absolutely. And there's so many math problems that involve parties and pushing tables together and having more people join. And so it's also a great extension to add on to another problem that you've done before. All right, folks, that's the Notice and Wonder. Is there a way to freeze the GIF? There is, and it's by taking a screenshot. So I'm going to hold down my window, Shift S. You all can see on my Zoom screen that it is paused here. And now I'm just going to put I'm going to paste it there on Group 3's slide so you can see where that part has frozen. Yeah, I'd like to take lots of screenshots to see what happened to that 8th piece. So I love this GIF. It was such a fun one to find. I was immediately drawn to the 7 plates and the 8 pieces. Awesome. All right, we're going to jump into the rich tasks, the meat of this PD here. I'm on slide 12, and I like to ground this in research. The reason why I focus on rich tasks in all of my classes is because mathematics is so much more than doing a procedure. It's about developing that procedure, asking questions, good conceptual understanding, having a productive struggle, and then using student thinking to guide our next steps so that we're all moving together, as opposed to watching what the teacher does and kind of repeating that. So as we go into this student-centered task, I'm going to offer a problem-solving oath. That's on slide 13. As I read it out loud, decide if you would like to take this oath today and pop your name in the chat box if you want to pledge it. It says, I, insert your name, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. And I see we already have some great problem solvers who've taken our oath today. On slide 14 are 5 different manipulatives that you might find useful for today's task. You're always welcome to use more, but I like to give at least 5 for people to play around with. And our task is on slide 15. This is a super fun one. There's more to it once you dive in. It says Danielle loved Pie Day. It was her favorite day of the year. She would bake mini pies, the size of cupcakes, and bring them for all her friends. This March 14th, Danielle brought 60 mini pies to school. In her first period class, she decided to keep 3/4 of the mini pies and give the rest away. On her way to her next class, she ate one. In her second period class, she decided to keep 7/11 of the remaining mini pies and give the rest away. On the way to her next class, she ate one. In third period, she decided to keep 5/9 of the remaining pies and give the rest away. On the way to her next class, she ate one. In fourth period, she decided to keep 2/7 of the remaining pies and gave the rest away. On the way to her next class, she ate one. In fifth period, she decided to keep 2/3 of the remaining pies and give the rest away. On the way to the main office, you guessed it, she ate one. When she arrived at the main office, she cheered, "Happy Pie Day!" and gave the office staff the remaining pies. How many pies did the office staff receive? I'm going to put you in your same breakout rooms as before. Feel free to use those manipulatives. I also got a little pie right there on the group slide if you'd like to use that. And I'll go ahead and set up those breakout rooms again. And Julie, yes, of course you can use that with your students. All right, breakout rooms are set up. Feel free to head in there and enjoy this pie problem.
Questions?
Ah, okay.
Because I can, I'm going to try doing some things here. Let's see. Text. But it takes me a while to do anything.
I'm trying the number tiles too now because I started with fractions, but I'm looking at it thinking fractions is just not going to work here. So, and I'm not even comfortable manipulating these things. So I'm looking at number tiles now.
I would probably use fraction strips, but not with the ones that are marked. You can just change the markings on them.
How how do you do that?
I don't know on this particular program. I think it's got to be in the settings where you can turn off the numbers. Teresa, do you know how to turn the numbers off on the fraction bars, or is that possible?
It is possible. If you go under the little tools on the right hand side, it looks like a hammer and a wrench.
Mm-hmm.
And you can label type. I want to say you can hide number labels. Yeah. So I'll demonstrate that again if you need to see it. So
I got it. Yeah.
yeah,
that
once
works.
you pull them over, the little tool thing lets you hide them or put them back on.
Cool.
Is there a way to stretch the, so I have my 60 tiles laid out. If I want to add a fraction bar below it, is there a way that I can stretch it or make it, shrink it and things like that?
Oh, because you want the fraction bar to be okay. So, kind of. Can you take a screenshot of what you have and put it on your group slide? Because we can actually do that in Google Slides. And if you want any help with the screenshots, just let me know. I'm getting better at doing it over multiple platforms.
We are group 1, correct?
Yes. Mm-hmm.
That's my screenshot. And I wanted to stretch out the red bar so that it kind of, the fraction bar,
Mm-hmm.
so that it spans the entire width of my pies.
Yes.
On the number thing, but I don't know how to do that.
So I have found this to be challenging because I also want to stretch it out. But what the program is doing is they're keeping the fraction bar proportionate. So what I've learned to do, what I'm doing here, and you know what, I should have let me make a duplicate of this before I start messing with yours. Okay. What I've learned to do is use a Google Slides because that allows you to change the proportions.
Okay.
What I'm going to do is crop yours. And then if I go to insert table and put 4 columns in it, it pops a table down below, and I can now stretch that to be the same size.
So we can't, in that polypad, we can't split them, the blocks.
Like split them in
That's why-
half.
You're right. Mm-hmm.
That's why I like the number tiles,
Mm.
because you can put them into factors and multiples and change the shapes of them. So let me see if I can get a screen capture. Let's
You
see.
know, even though we can't take these apart, though, we can still do some really cool stuff with them as is, like especially when we bring them into the Google Slides. I'm going to kind of leave this here for you all if you choose to use it, but we can put these little dotted lines in.
That's true. Yeah.
And I took it and by using the number tiles, I put out 60 and I could join them, but then I could shape it into different, using different factors of 60.
Tell me more about the shape it. What were you doing there?
I changed the shape so that it was 5 by 15, was it?
And
Yeah.
why is that a really good shape?
What? 5 by... No, I wanted...
12.
Wait a minute, 60, 15, 45. I wanted 5 by 12. And then 5 by 12 so that I could give away, and I could color those, and then I could put the keep as one color. And I can copy that keep. Then, which is what I'm going to do now.
So Gail, it might be useful for your group if you want to do a screen share so they can kind of see what you're doing, and then everyone else can also do that. But the math that's happening here that's really cool is when you said you're going to resize the shape. There's something very
love that.
mathematical happening when you resize it. So you all keep thinking about that. You can share screen and showcase that with your group, and keep working on this. Y'all are on the right track.
So do you all want to see what I'm working on?
Usually.
Okay. So slide 18 is available. I'm going to keep working on my table on slide 17 because I think I'm getting there. I'm just thinking individually right now, and somebody can check my math here as we're doing all these different approaches. It's cool. 5 minus 1, 9 is 3, 8, 1 is 26. 8, 2, 7, 6. Oops. I think my math is wrong now. Oh, what did you get for an answer?
Hang on, I'm checking your work.
Okay, I'm stuck in block 4.
Wyatt, I can see that. I'm looking at it. Hang on, I'm trying to compare it to my scribbles on my notepad.
Okay.
So I'm with you at the 27. And then we get 15. She eats one. If you eat one from the 15, you have 14.
There we go. Phew.
Yeah,
okay.
That's okay.
So 2 sevenths, a seventh of 14 would be 2. So that's 4 cupcakes because that's 2. I'm just trying to capture my thinking. 2 times 2, right?
Right.
Does she eat one on the way? Yes?
Yep.
She eats one.
Yep.
So now, is there a block 5 or is that the office? Oh no, there is a block 5. And we now have 3 cupcakes, correct, Colette?
Right.
Okay, so at block 5, keep 2/3.
So that means that she's going to give away 10.
So I almost, like, I know we started, like, I built the matrix, the array. So now I almost want to do like a table to keep track. Like, I know we're doing a running tally on the side, like a table to keep track of like how much she has at each step.
Mm-hmm. You're really good at that. Do you want to build that? You're good at tables. Put this over here. So then we're done with this part.
Mm-hmm.
Wait till next class, she ate one. That's a lot of pies, girl, for one day.
Yeah, but they're only cupcake sized.
That's still a lot of pies. For someone who has already a lot of sugar in her body, that's still a lot of pies. She ate one, and after she decided to keep 2/3 of the remaining pie. So an observation I made is that every time we changed what multiple we worked with, but it was still a multiple that we were able to like grasp.
And that's what I was talking about, how when I first saw the fractions, I was like, oh, 7/11ths, that could be tough. But then the numbers were really friendly numbers to work with those.
Yeah.
I think that even though there's a lot to this task, it's a great entryway into things simply because of the fact that the numbers are so challenging that they get lost in the actual math. It allows thinking to happen and that work with fractions in a way that wouldn't necessarily scare them.
Well, and I think the fact that we had an array where we could count out and we could see and we could change the colors, I think that visually helped. Because I know like as we went along, we were talking through like how we figured out the fraction pieces, but I think having like that color helped.
I'm trying to label the colors so that we also could keep track. So this was the first one. Okay, so this one was the first one. And then second. And then this was the fourth one. And so the fifth, she had 3 left and she gave 1/3 away. On the way to the main office, she had 1. So she had 1 pie left. And she gave the office 1 pie.
Very generous.
It's kind of neat because it ended up being right there kind of towards the center. It's not,
And we didn't even plan it that way.
Oh, I hope she copies the 6 in the right font before she takes it. Oh, she did. Okay.
and then I think it would be neat to ask the students what fraction of the pies did she eat? Especially with this video.
Oh, yes.
Should be pretty, I mean, they've got a visual there to then do that.
Hi there, group.
Hi.
I see in your image, you have a lot of great imagery here. I can see the part where she gives away 1/4. But how did you get the number 2, all those like navy blue pieces? How did you figure out how many to change to that color?
So we used different shades of blue to talk about how much she was giving away each time. So the first shade of where it says 1, that's the first time. That was the first period she gave away that much. And then the second period was the darker blue, and that's how much she gave away.
And 7/11 is a wacky fraction. I mean, that's not a friendly number at all. How did you figure out how many to give away? Like, I can see navy blue, but how do I know that that's the right number?
That was,
So, go ahead, Julie.
that was one of the things that I really liked about this problem. Even though 7/11 is kind of an intimidating fraction, especially for students who may not have a good solid background. The fact that she had 45 after she gave 1/4 away, and then she ate 1 and that left you with 44, which is a number that worked really well with 11. So you could kind of look at those relationships and look at how you could do equivalent fractions with 44 and 11, and look at that scale factor of multiplying by 4, 28 44s, which would be what she kept. So that then you could just kind of say, well, if she kept 7/11, that means she gave away 4/11. And so there could be a whole lot of discourse on that piece.
I see. So you knew the scale factor, and that made it so that you could figure out that number 28.
Yes.
Cool. All right, these are looking great. Hello, everyone, and welcome back to the main room. I know many of you all wanted even more time on this task, and it is such a great task to do, where we bring really unfriendly fractions and we make them friendly based on some multiples, some factors, fractions, and more. And the purpose of our whole class discussion is to bring together some of the ideas that we came up with in our small groups and talk about how these unfriendly fractions can actually be quite friendly. And I'm going to start us off on, where are we? Slide 24. If you would head down there. And what we're seeing on slide 24 is all about the shape of the pies. And I can almost imagine Danielle walking down the hall with this like box of them, where they might be in the box in different ways. And so here we've got 3 different images of 60. And I'm going to start off with group 1. I know that you all have done so much more with this one, but let's just start off with the 60. Why do you have these 2 bluish purpley color shapes? What was your initial thinking about the shape of the 60 pies?
So I was, I had to remember because we redid it. We had the 60 pies, and I took number tiles in Polypad in Mathicon, and I can reshape those 60 tiles using 2 different factors of 60 factor pairs. And you can reshape it different ways and into different rectangles. And so I tried to make something I could divide into quarters. So a 5 by 12, what's it? Rectangle divided into quarters nicely. But we changed it at the end then.
Yeah, and I'm actually going to have you kind of give us a little run through of what you did at the end. It was such a great way of using that manipulative. So yes, thanks, Gail. And in that group 1, they started making these shapes. But I have a question for everybody on slide 24, and there's boxes for you to fill your response in. 60 cupcakes can be cut into 4 groups. What shapes are useful? What Gail just said is she wanted them to cut them into quarters. So what other ways could we arrange the shapes? And you can feel free to move your text box around and make more room. And while you're putting those in, can I get someone from group 2 to explain the green one? Like, why did you use this shape?
Hi, Teresa. We started doing a table, and we actually calculated it using the table. And we were struggling with coming up with a visual because Kathy was basically sharing, and Kathy, you may want to explain it from here, but Kathy was sharing how she uses a fraction bar model with her students. And I started visually, finally grasping what she was doing. So what I did was using the fraction tool, made it 60, equally divided that into 4 sections. She obviously, if she's going to keep 3/4, that means that she's giving away 1/4 of them. And then what I would have done was crossed out the one that she ate. Now I have clear 44. Take that new 44, use a new color, and divide that up into how many sections ever? I think it was like into 11 sections, and basically shade up and gradually show it from the original 40. That's what I was trying to do. Hope that's what Kathy was meaning, because that was the idea I was getting.
Okay, so I'll try to explain it as well as I can. So if you start out with a bar model that is just a rectangle, and that is technically your whole unit. We started out with a whole unit of 60. We know that we gave away 3/4, or she gave away 3/4, correct?
Mm-hmm.
Yeah, so you give away the unshaded piece right here. So you give away 45, and then you would take away one of the green pieces because she eats one. So I would copy that model. Yeah, you would have it multiple times, and you would start with that 60 model the entire direction. So the first piece, the unshaded, that's the part we gave away. We would take one more of the green shaded away on the second bar model. That leaves us with 14. We now need 2/7 of that 14. So we're going to take that 14 pieces and divide it into sets of 2s and see how many we get. So if we notice that when we divide that 14 section into 2s, you're going to get 4 14ths.
Okay, and that goes with your table, right?
I don't have anything to do with the table. I was only doing the bar modeling to show the logic and reasoning to my students of what is happening step by step.
And you started off with just this, like almost a tape model, this 1x60.
Yeah, it's just a 1 by however long.
So that is a really cool way of looking at it. Even though you're doing a fraction model here to show a 1x60, it's very similar to a number line model or a tape model where it's 1 by however long it is.
Yes.
Awesome.
Yes, because if you just have one unit, then if you had a piece of tape, right, you would fold it the first time, you would fold it into half and you would say how much is each half, and they would say, oh, it's 30 and 30, and then okay, half of that, and then we have 4, so how much is each of one, out of 3/4, how much is 3/4, how much do you have left? You cut that off and you have your 15 left. From there you're like, well, how much did she eat? Well, you cut one off, which means you have 14 left. So now let's go ahead and do this again.
Let me go ahead and model what you're mentioning here, and that is actually going to lead us right into the next part. So we've got this 1x60, and I'm going to crop off the green.
Okay.
And so then, what did you say happens next?
No. Okay, so the green is the part we're actually keeping, isn't it? Because she gave away 3/4.
So let's see. She decided to keep 3/4.
Okay, yes, perfect. Okay, so yeah, we're going to keep the white section. And then we've got 45 there. So if you highlight and copy just the white section and bring that down to stage 3. And sorry, I don't know.
Oh no, this is exactly where we're going to go. Kathy, I'm going to kind of switch us over briefly to the table so that we can come back to this representation here. Because there's a connection happening between the tape model and the table. So who did the table on slide 25? Can you start to explain to us what's going on here? And we're going to come back to the tape model and make a connection.
Sure. I started this and Colette was helping with me and checking accuracy. We ended up splitting in 2, knowing we'd have a visual and a table. And so I was just thinking mathematically about it. If we had 60 cupcakes, we keep 3/4. So what is 1/4? 1/4 of 60 is 15. And we kept 3/4 of that. So that's how we figured out there were 45 cupcakes. And then she ate one. So the 45, or mini pies rather. Oh yeah, we changed it to mini pies. 45 mini pies, she ate one, then we were starting with 44 mini pies.
Okay.
And then thought about it in the same way. What is 1/11 of 44, which is 4, and there's 7 of them, so there's 28. And then she ate one, so then we have 27. So yeah, the table and the visual that they created, Kathy and Rowena were working on it. It just matches perfectly.
So this tape model keeps getting eaten up each time.
Yes.
Ha, cool. So we can have a tape model that keeps getting eaten up each time. But this group also has some interesting little multiplication kind of moments in here. Can you all explain to me what is this 3 times 15. What is this 7 times 4? What's going on with those things?
So that's where we were thinking of, okay, so in period 1, we wanted to find 3/4, but what I was thinking about is what is 1/4 of 60? So that's the 15, but we need 3/4 of them. So then it's 3 times the group of 15 mini pies.
So that 15 is related to how many we are using right there, that 45.
Yeah.
Interesting. But is the 15 related to the next fraction down, the 7/11ths?
Sorry, I have to think about that.
Yeah.
No, because when you lose one cupcake, it has an impact. We had 45 and it was related, but then we lose a mini pie rather, and we have 44. So the 15 is not related anymore to the 44 in the next period.
So now we have a 44. It doesn't relate to the 15. It's really annoying, except all of a sudden it's actually kind of useful. And group 3 started figuring out why the 44 was so useful on slide 28. So if we want to come on down to slide 28, this group was starting to explain to us why the 44 was so useful now. Can you all kind of give us an explanation of that?
Hi, Teresa. It's Raha. So I wanted to tie my comment with your question because it relates to the question. Basically, when I started reading the problem, I was very overwhelmed that she was eating every time. And I was like, you're making my fractions. You're messing up my fractions. But then I figured out, actually, she was helping me because the amount that was either she kept or being given away, the denominators are unfriendly to us. So like 7/11 was unfriendly to us. However, because she ate 1, we had 44. 44 and 11 are multiples of each other. So I was able to or as a group, we were able to be like, oh, okay, so we can now find how much she gave away because of the denominator, if that makes sense.
Yeah. Our 44 made this so much friendlier all of a sudden. We do just have a couple minutes left, so I want to showcase some other ways that students have done this in case you want to do a problem like this in your class. If we could come down to slide 29, I'm going to ask for us to kind of do a little group effort here. On slide 29, we have, thanks group 3, 60 pies. And one way that students solve this is they start to divvy out. Give, keep, keep, keep. Give, keep, keep, keep. Give, keep, keep, keep. The idea that we're starting with early division, we're not really sure how many it's going to be. And students might model that by going, a give is purple, 3 keeps are blue. A give is purple, 3 keeps are blue, and so on. If there's someone or a group of people who want to continue this model of give, keep, 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 so we can see what that first stage looks like, feel free to go ahead and do that. And that's the idea that, our early number sense isn't quite there for saying, oh, 44 is nice for 11. We don't know that it's nice. We're going to continue to keep, give, give, give. And then the other thing that students really develop with this is the idea of arrays. So the 60, we already heard initially that it's really easy to split up into quarters. And so I think this slide came from group 3 also, where we could take this and we can clearly see 1/4. So that's kind of using our area model to see the 1/4, and we can take that out. But then the neat thing is, what do you do with the leftovers? So as we have someone doing the keep, give, 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 I'm going to go ahead and duplicate this to show, whoops, why can't I do that? There we go. To show what happens when we start to rearrange these leftovers. And those were some of the questions I started to get to, but I left some of them out. If we were to take the leftovers and move them around, we could actually get 11 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And move these others so that it makes a nice, beautiful little array of 11 pieces once you take out that one that she eats. And now we can clearly see the one that she eats sitting out there. And we can take out our 7/11 with a similar rectangle and kind of continue with this array method. And then we can rearrange, and then we can find the leftovers. As we finish up, I did want to mention that Gail found a neat way of doing these rearrangings in Mathagon, and I'm going to pull her work down here onto our slide so you can see what she was working with. And Gail, would you tell us, is there a way that this app makes it really easy to move the pieces around?
So in this Mathagon, you can put out number tiles, and when they're merged, you can drag it into different rectangular shapes or rectangles with a corner missing, for if your number was not divisible by something else. And you can make all kinds of different shaped arrays. And you can merge them back together again then, and I could color them for the giveaway, and I could pull one off separately when they're separated. You can split the tiles, pull one away that she ate, and then merge them back together again and make a new rectangle shape after she ate one. So that we started out with the 60 and 4 columns, and she gave away a quarter, and then pulled off one that she ate, put it into 11 columns, and it's really nice. I can share if you want me to.
So yeah, if you want to go ahead and do a share screen, if you already have those up, what's really neat is...
Teresa, you're muted.
Thank you. Yeah, go ahead and share your screen so we can kind of see what you're doing. I took mine off. And while Gail's doing that, what I want you to notice here is the usage of the tool. So if we've got kids who are still trying to figure out arrays and how to make arrays, what's neat about this tool is that it takes that struggle away as they're trying to figure this out. So
here's the 60. Here's the 60, and you can change it into different shapes, and you can see that, you know, I can have something that's 5 columns and 12 rows. You can put it the other way. You can see that 60 is divisible by 5 and by 4 and by 6, but it's not divisible by 7. And you can move that around all kinds of different ways. I really like playing with it.
So it keeps our area the same, and it just kind of changes the orientation of the pieces so that we can find arrays. We can find that extra pie that's sitting there and break them apart more. All right, folks, that brings us to the top of the hour. If anyone wants to continue playing with Mathagon, definitely let us explore together. But thanks for joining us. I hope that you've got some really neat ways of talking about multiples, talking about arrays, factors, fractions, ratios, and more in this task. And we can thank Mickey for getting us excited about separating cakes into fractional pieces. And you guessed it, he ate one of them. So thanks for joining me, everyone, and happy MATHurdays.
Bye-bye.
Bye-bye.